Welcome to Chapter 1. Every time a web page loads, your computer and a server somewhere else in the world run through a fast, multi-step negotiation. By the end of today, you'll understand every piece of it well enough to eventually build the thing on the other end. We'll cover the client-server model, DNS, ports, HTTP versus HTTPS, and close by getting a real file live on the internet. Quick roadmap before diving in. By the end of today, you should be able to explain the client-server model, describe how DNS resolves a name to an IP address, know what ports 80 and 443 are for, explain why HTTPS matters, organize a project's files using our standard folder conventions, tell a sitemap apart from a wireframe, and write a minimum valid HTML5 file. We'll hit every one of these in order. Start with the question the whole chapter answers. What actually happens when you type a URL and hit enter? In the time it takes to blink, your browser has to figure out which physical machine that name refers to, connect to it over the right channel, send a request, wait for a response, and render what comes back. All of that happens in a few hundred milliseconds. Today we're slowing it down to look at each piece. Two terms to introduce now and use for the rest of the semester. Your browser is the client, the machine hosting the site is the server. That relationship is the client-server model. We'll come back to it properly in a few slides. This is the visual version of what we just described. Request goes out from the browser, hops across routers, reaches the web server, and the response comes back the same way. This whole round trip is what's happening in that blink of an eye from the last slide. We're about to zoom into each piece of this diagram individually, starting with how the browser even knows which server to send the request to in the first place. Computers don't actually understand domain names. Underneath, everything runs on IP addresses, numbers like 192.0.2.10. So the very first thing that happens when you load a page is a DNS lookup. DNS stands for Domain Name System, and its whole job is translating a name into an address. Your browser essentially asks, "What's the IP for this domain?" and gets a number back. Good analogy to lean on here. DNS works exactly like the contacts list on your phone. You tap a name, your phone looks up the number for you. Walk through both halves of this slide together. Top half is the contacts list analogy made concrete. You want to call Carol, your phone looks her up, finds her number, now you can call. Bottom half is the same idea with real DNS terminology. You type a domain, your device asks a DNS resolver, the resolver asks the authoritative DNS server, the IP comes back down the chain, and your device connects to the web server using that address. Emphasize that this whole exchange happens before a single byte of the actual web page is requested. Knowing the IP address alone isn't enough. One server can run multiple services at the same IP, so your browser also needs to know which port to knock on. The analogy that sticks. The IP address gets you to the right building, the port number gets you to the right apartment inside it. Web traffic uses two ports by convention, 80 for HTTP, 443 for HTTPS. And that's exactly why you never type a port number into a normal URL. The browser already knows. HTTPS:// means port 443. This diagram puts the two protocols side by side. Top half, port 80, HTTP. Request and response travel as plain text. Anyone intercepting that traffic can read it. Bottom half, port 443, HTTPS. Same request/response shape, but everything's encrypted end to end. Point at the table at the bottom. Same structure, different encryption column, different security outcome. This is the visual we'll come back to in Chapter 10, when we talk about why HTTPS matters for anything handling real user data. HTTP is the shared language browsers and servers use to exchange requests and responses. It's the grammar underneath every page load. The problem is that plain HTTP sends everything in plain text, so anyone intercepting the connection, like on public Wi-Fi, can read it. HTTPS wraps that same conversation in encryption, using TLS browser and server handshake, agree on keys, and everything after that is scrambled to anyone but the two of them. Worth saying out loud, HTTPS protects the connection, not the whole site. A site can run HTTPS and still have weak passwords or vulnerable code. This matters most anywhere you're collecting real data, forms, logins, anything personal. Now we name the relationship properly. Client is your browser, it makes requests. Server is the host machine, it sends responses. The cycle is always the same. Request, process, response, render. Worth flagging ahead of time. Later this semester when we get to PHP, you'll be writing code that runs on the server side of this exact cycle, generating a response dynamically, instead of handing back a file that was just sitting there already made. This pulls DNS, ports, and the client-server cycle into one picture. Top box is DNS resolution 4 steps, ending with your device holding an IP address. Bottom box is everything after that. Connect to the server over 80 or 443, the server processes the request, sends the page back, browser displays it. The strip at the bottom compresses all 8 steps into a 5-stage summary. This is the complete answer to what happens when I hit enter, start to finish. Same story, slightly more detail. This version spells out what the server processes the request actually involves, receiving it, running whatever application logic is needed, possibly querying a database, and generating the HTML/CSS, JS that gets sent back. That's a preview of everything from Chapter 7 onward. The callout at the bottom is worth reading aloud. TCP, TLS, CDNs, firewalls, load balancers, all real pieces of this puzzle we're intentionally not opening today, because the goal right now is the big picture, not every layer underneath it. Before writing a single line of HTML, professional developers plan their file structure. A project where every file lives in one folder becomes unmanageable fast. Our standard is 4 folders: images, scripts, media / and styles for CSS, starting next chapter. Also flag naming. Flowers.jpg tells you what it is. Something like img2_final_v3.jpg doesn't. Get students in the habit now, because it only gets more important as projects grow. This is how a file actually gets from your screen onto a real server, connecting via FTP on port 21 to your subdomain. Because we're using WebExpression 4 to edit the live file directly on the server, rather than working locally and uploading afterward, there's no separate publish step. Saving the file and publishing it are the same action. Worth a brief aside. FTP itself is unencrypted. That's fine for our classroom workflow, but production environments typically use SFTP or FTPS instead. 2 planning documents that are easy to confuse because both happen before any code gets written, but they answer completely different questions. A sitemap answers, what pages exist and how do they connect? It's structure, not appearance, usually drawn as a tree. A wireframe answers, what does this one page actually look like? Where's the logo? Where's the nav? Where does content sit? Sitemap first, then a wireframe for each page on it. We'll build wireframes directly, starting next chapter. This breaks down the 5 required pieces of a valid HTML file and shows what each one actually does, side by side with the real code. DOCTYPE declares HTML5 rules. HTML wraps everything. Head holds page info that isn't directly visible, right now just the title. Body holds everything that actually displays. Point out the bottom callout. Most elements come in opening/closing pairs, and forgetting the closing tag is one of the most common early mistakes. Here's the complete minimum valid HTML5 file. 5 pieces properly nested in order. DOCTYPE first, then HTML wrapping head and body. This exact structure is what you'll type at the top of every HTML file for the rest of the semester. Manix doesn't change. Have students type this one out themselves rather than copy-pasting. It's short enough to be worth the muscle memory. Worth covering explicitly, because everyone makes these exact mistakes at some point. Skip the DOCTYPE, and the page may still render, but the browser can fall into quirks mode. Unpredictable spacing and sizing once CSS gets added next chapter. Skip head or title, and the page still works, but the browser tab shows a blank or generic label. Forget to close a tag, and the browser guesses what you meant, often wrong. The takeaway to land: close every tag you open, every time, as a habit. This is the whole chapter compressed onto one slide. Good one to linger on before moving to assignments. Left to right, top row DNS as the internet's contacts list, the client-server round trip, ports as apartment numbers with the HTTP/HTTPS comparison table. Bottom row, folder conventions, sitemap versus wireframes side by side, and the 5 pillars of valid HTML stacked as blocks. If a student can explain every box on this slide in their own words, they've got the whole chapter. 2 assignments and a quiz this week. Assignment 1 is building your folder structure, images, scripts, media, uploaded to your subdomain. Assignment 2 is deploying your actual hello world, a valid index, HTML, live on your subdomain, reachable by anyone. The quiz covers this chapter's core concepts: DNS, ports, HTTP, HTTPS, and the client-server model. Point out that Assignment 2 is the moment everything in this chapter becomes real, their own file, live on the actual internet.